Pressure! My name is Brian King. I am in the October physics class at 1 p.m. And today we're going to be talking about the transference of energy. And to do that, we're going to be using some AA batteries, product placement, some chocolate, and some aluminum foil. And so let's get started, shall we? I want to unpackage these batteries. We're only going to use one, so if you have spare batteries lying around, this works, but I just bought a new pack just to kind of show you. And it's just a regular, what is this, a AA, positive, negative. Batteries work with electrons going through the positive and negative ends, and then they run through wiring or something that's conducive, and it creates a circuit, which is why we have the aluminum foil. So we're going to take this battery, I'm going to put it over here actually, I'm just going to pull a piece of aluminum foil off. Sometimes you just have to get really physical with your aluminum foil. It doesn't have to be a big piece, just something small. And we're actually going to wrap the battery in it. And what this is going to do, since aluminum foil is pretty conductive, it's going to send the positively charged electrons through this foil, which conducts electricity, and it's going to send it back to the negative because we're going to wrap it. So you want to make sure that your positive and your negative end, which is currently being wrapped, are both securely placed in your foil. And what will happen is, if you do it right, is it will get hot. And we're gonna prove that it gets hot, which is why we have the chocolate. Just to prove the series. So we're gonna melt this. And it's not gonna get terribly hot. It gets warm. So we're gonna melt some chocolate. Delicious. And you can actually, I've seen experiments where they like pop a balloon or they melt a plastic bag. Oh, this chocolate's being difficult. Now it's getting nice and toasty. Do 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 do. You can snag a bit for yourself. Why not? So, I don't know how long this is going to take. I'm just going to hold this here. Do 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 do. La da da da. Dee 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 dee. Ah, it's working already. You can see, actually, I'll make it a little bit better, but let's see if we can mold it. Now, again, how this is working is, since the aluminum foil is conductive and the battery produces a charge, it sends the positively charged, oh, now it's working, oh dear, oh, we got melted chocolate. There we go. Get your melted chocolate and your battery. And again, positively charged ions going through the positive end of the battery. They circulate through the foil because it is conductive. The foil will be conductive. So if you had a piece of wiring, you could do the same thing and create a circuit. That's how they make circuits. You know, if you see like one of those typical light bulb experiments, delicious. They have one end going from the positive end to the light bulb, another cable going to the negative end, and it lights the light bulb up. And that's all the proof you need, really, to see that it did heat up. No cuts, no edits. Just the works, man. And that's physics.